Hello, my name is Isaiah Ofalt,
And I am Kyle Sefaradi.
and this is our number recognition using a neural network Matlab.
So our neural network is made up of a neural network in general is made up of a lot of functions. You need to define your alpha and how you're going to move from your inputs into your hidden layer, which is then used as part of the sigmoid function. As you can witness here, you have your xi, which is based off the proportion of white squares in our matrix subsection, and that's going to be our input, which is going to go into our alpha. Then our alpha is going to represent our hidden layers. And then you have our hypothesis function based on the sigmoid.
Alright, as you can see here, our input is the 8 different sections that we broke down the number into. We'll explain more on that later. And basically, the input goes through the sigmoid function that determines what it is, and then it goes out to the output layer in the output, which is 4 different options: 0, 1, 2, or 3. And then right here you can see this is just the zoom in the code, and basically what happens here is it'll go through and it'll determine whenever it'll come from the left, and it'll find whenever it gets to a value that is substantially different from black, it'll delete all the numbers on the left, and it'll go through and do the same thing on the right. Once it hits a value that's substantially different, deletes only the columns on the right, and it does the same for the rows above and below.
Our next portion of the code consisted of making the 8 input functions. The matrix bitmap file of an input number was broken into 8 sections, where the H represented the half and the Q represented the quarter. And each of these were used in the code over here on the right to break apart any size input matrix, so it's not dependent on a specific size image. And it uses a ceiling-like function, so it will round and it'll perfectly fill the entire matrix without error regardless of the input size. It then takes the proportion of the white to the whole, and it uses that proportion as its xi value as it enters it into the equation that Isaiah just mentioned. So this is our actual test. We created a neural network using 41 different options, and we did some training data and we tested it, and you can see our results are very good overall, 97.6% accurate. So we're going to bring you to the actual code right now. So this is in Matlab. First, we did a decode numbers in Matlab, and this represents how we take a bitmap file and actually convert it into a processable image that a machine can learn from and understand. So this is the code Isaiah mentioned that actually zooms in on the number regardless of the size or the rectangle, square, however the input is, it'll zoom in right on the number. And then this is the code I just mentioned that breaks the matrix into sections. And you have your neural Y, which represents the first number is probability it's a 0, second number probability it's a 1. And right here, since this is input training data, we say that it is a 1. So we have a 1 right there, and then all our x's that represent the chance of getting that 1 are below in the neural x's. And we repeat this at least 10 times for each number. 1 we did 11 times, and so overall you have our 41 input numbers right there. So then we created this neural network zoom function because it combines the zoom along with our neural network capabilities, and anytime we input any testing image into this function, it'll give us a probability that the function is either 0, 1, 2, or 3, as Isaiah mentioned being the 4 outputs. So you see here, if we type in nn zoom and z, z would represent whatever matrix we set as z. So in the top of decode numbers, we have our own section just to test the data. So we can go to test 0_1. This is the first test to test the number 0. So ideally we would want the code to turn out 0. We run section just so it's enough to give us this Z value, which represents the X's. We do NN zoom on Z, and as you can see we have a very high probability that this is a 1. And note none of these test image, or this is a 0, sorry, because it's the top, yes. And none of these test images were used in the neural network code. And then we have test 0_2, a second 0 that we can try. We run the same thing, and you see 99.6% chance it's a 0. We can try out 2_1. This should be a 2. We get a new Z. As you see right there, we have a 2. And you can do that for our other test data as well. Right there you have a 3. So you can try that if you'd like to.
And the code actually works so well that we decided to, just as something fun, try a different looking number. And I'll just type it in right here. We call this one Funky Man. Nope. And here's the file that we picked.
Notice how long the image is itself, so we'll have to zoom in on it as well.
Oh. Yeah. And here you can see that it has a very high chance of being a 0, which is really nice considering the image was so long and so wide, and that the 0 had arms and legs.
Yeah. So this was just a lucky find, you could say, but it represents just the quality of the code in breaking apart a given image based on proportions. So we have one last slide for you.
And
we would like to conclude with saying
we got one good algorithm.
And 10 out of 10 would recommend to a friend. Thank you for your time.